Alright, so in this problem, I have x to the power of 21 plus x to the power of 14 is equal to 36. So I'm first going to rewrite x to the power of 21 as x to the power of 7 to the power of 3, and then we write x to the power of 14 as x to the power of 7 to the power of 2. Now this is equal to 36. And now I'm going to let the variable y equal to x to the power of 7. So now I have y to the power of 3 plus y to the power of 2 is equal to 36. Now if I subtract 36 on both sides, I get y to the power of 3 plus y to the power of 2 minus 36 is equal to 0. So now to solve this, I'm going to write this as y to the power of 3 plus negative 3a squared plus 4a squared minus 36 is equal to 0. So all I did was I simply rewrote y squared as negative 3a squared plus 4a, or sorry, this is y, not a. So I simply rewrote y squared as negative 3y squared plus 4y squared. And now from here, if I factor out y squared from y to the power of 3 plus negative 3y squared, I get y squared times y minus 3. And now if I factor out 4 from 4y squared minus 36, I get 4 times y squared minus 9. And now this is equal to 0. Now y squared minus 9, that's the same thing as y plus 3 times y minus 3. And now from here, if I factor out y minus 3, I get y minus 3 times y squared plus 4 times y plus 3, which is equal to 0. And now if I simplify that, I get y squared plus 4y plus 12 is equal to 0. So now this gives me two equations. I have y minus 3 is equal to 0, and I have y squared plus 4y plus 12 is equal to 0. So for y minus 3 equals 0, y is obviously equal to 3, and for y squared plus 4y plus 12 equals 0, well, if you actually put this in the quadratic formula, you get the square root of a negative number, and you can't take the square root of a negative number, so this is wrong, and the only solution for y is y equals 3. So now going back, remember how we let y equal x to the power of 7. So we know that y equals 3, meaning 3 is equal to x to the power of 7. So if 3 equals x to the power of 7, all I have to do is take the power of 1, 7 on both sides, and I get the 7th root of 3 is equal to x. So this is my answer. Alright, so in this problem, I have 40 to the power of 40 over 20 to the power of 20. So first off, I'm going to rewrite my exponent 40 here as 20 plus 20. So now I have 40 to the power of 20 plus 20 over 20 to the power of 20. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 40 to the power of 20 plus 20, I can write as 40 to the power of 20 times 40 to the power of 20. Now I have this over 20 to the power of 20. Now, I can rewrite this as 40 to the power of 20 times 40 to the power of 20 over 20 to the power of 20. And 40 to the power of 20 over 20 to the power of 20, if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So this can equal 40 to the power of 20 times 40 over 20 to the power of 20. This is equal to 40 to the power of 20 times 40 divided by 20 is obviously 20. So times 20 to the power of 20. Or sorry, 40 divided by 20 is 2. So I have 2 to the power of 20. And now, if I have something in the form a to the power of m times b to the power of m, this is equal to a times b to the power of n. So 40 to the power of 20 times 2 to the power of 20, that's going to equal 40 times 2 to the power of 20, which is equal to 80 to the power of 20. So this is my answer. Alright, so in this problem, I have x to the power of x to the power of 3 is equal to 36. So to solve this problem, the first thing I'm going to do is I'm going to take the power of 3 on both sides. So now I have x to the power of x to the power of 3 to the power of 3 is equal to 36 to the power of 3. Now 36, this is the same thing as 6 to the power of 2. So now I have x to the power of x to the power of 3 to the power of 3 is equal to 6 to the power of 2 to the power of 3. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 6 to the power of 2 to the power of 3, that's going to equal 6 to the power of 2 times 3, and 2 times 3 is 6. So now I have x to the power of x to the power of 3 to the power of 3 is equal to 6 to the power of 6. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And m and n, I can actually switch the place of these two because in multiplication, you can switch the place of these two numbers. So this is the same thing as a to the power of n times n. Well, if a to the power of m to the power of n is equal to a to the power of m times n, and that's equal to a to the power of n times m, this means that this is also equal to a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is the same thing as a to the power of n to the power of m. So you could switch the places of these two exponents. So in this case, I have x to the power of x to the power of 3 to the power of 3, and I can think of x to the power of 3 as m and 3 as n. So this is the same thing as a to the power of n to the power of m. So if I switch these two places, I get x to the power of 3 to the power of x to the power of 3, which is equal to 6 to the power of 6. Now I'm going to let x to the power of 3 equal to the variable y. So now I have y to the power of y is equal to 6 to the power of 6. And if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, y is equal to 6. Now remember we set x to the power of 3 equal to y, meaning 6 is equal to x to the power of 3. So to solve this, all I have to do is take the cube root on both sides, and I get the cube root of 6 is equal to x. So this is my answer.